So in this lecture for S2 BCom CA and Corporation, we will be looking into determinant of a matrix. Determinant of a matrix. So determinant of a matrix means it is a number that is associated with a square matrix. So that number can be a positive, a negative, or a zero. And we use the determinant to find a solution to system of simultaneous equations. So the determinant of a matrix is normally represented in the form either in this way, or we say det of A. So let's consider a determinant of a square matrix, that is 2 by 2 matrix. So determinant of a 2 by 2 matrix. So determinant of A is equal to, in general format, we consider A11, A12, A21 and A22. So if this is the matrix, you need to find the determinant. What you have to do is you need to do a cross multiplication. And the upward direction will be noted in green, which is a sign, negative sign. So the answer will be A11 into A22 minus A21 into A12. So determinant of A is calculated in such a way that it is a cross multiplication. So cross multiplication of A11 into A22, the upward direction will be a negative sign. So A21 into A12. Now let's consider a 3 by 3 matrix. So this is a determinant of a 3 by 3 matrix, and the matrix will be varying from A11, A12, A13, A21, A22, A23, A31, A32 and A33. So this is the matrix you need to find the determinant of a 3 by 3 matrix. So let's consider the first element A11. So I'm taking this particular element. So I'll write A11. Then what I have to do is, whenever I'm selecting the particular element, I need to cover the element containing corresponding column and the element containing corresponding row. So I'll get a sub-matrix. So this sub-matrix is called minor. This sub-matrix is called a minor. So I write A11 into, and I'll put that in a determinant form, A22, A23, A32 and A33. So the sign of this particular is identified in such a way, it will be starting with a positive, a negative, a positive, and if it is a 4 by 4 matrix, it will go like in a sequence order: positive, negative, positive, negative. So if it is a 4 by 2 matrix means 4 by 4 matrix means it will be a negative sign after. So the next element is A12, so minus A12. Now I have to consider the element, this one. So green is the element that I have to consider. Now what I have to do is I need to cover the element containing 1, 2. So I need to cover, or we need to delete the particular column containing A12 and delete the particular row containing A12. So that submatrix is a minor. Okay, and I'll call that as minor of 1, 2. So it is A21, A31, A23 and A33. So the next element will be plus A13, plus A13. So I'll consider this element now, A13. This is the element. Now, what I am going to do is I will cover the particular column containing A13 and cover the particular row containing A13. So I'll get the submatrix. That submatrix is called minor of A13. So that is a determinant of A21, A31, A22 and A32. So this is indicated as M11, minor of M11, minor of M12, minor of M13. So this can be written in short, A11 into M11 minus A12 into M12 plus A13 into M13. So this is how we find the determinant of a 3 by 3 matrix. Okay, so this M is called minor. This is called minor. So minor of an element of a matrix means it is defined as the determinant of a submatrix. Suppose if we are covering this particular row and this particular column, so we'll get the element of this one. This is the submatrix of this particular element. So minor of A11 means this is the determinant of the submatrix. Okay. So if it is A12 means it is a determinant of A21, A31, A23, A33. So likewise it's called. So that is what a minor of an element. So minor of an element of a matrix is defined as the determinant of the submatrix. So this is the determinant of the submatrix and it is obtained by deleting the particular row and column of that particular element. So I consider the element A11, so I cover up the column and the row, I get a matrix. The determinant of matrix is called minor of A11. So that is M11. Minor of A12 is M12. Minor of this particular element is M13. So this is all about minor of an element. Now let's see what is a cofactor of an element. Cofactor of an element. Cofactor of an element. Cofactor. So cofactor of an element equation is Aij is equal to minus 1 raised to I plus j into Mij. This is cofactor of an element. So the cofactor of an element of a matrix means there is a sign associated to this minor. Sign associated to this minor is defined with the help of a cofactor. For example, let's consider an example. So let a matrix A is equal to 1, 2, 3, 4, 5, 6, 7, 9, 10. So we need to find the determinant of this particular matrix. So determinant of a matrix A is equal to, we rewrite the matrix in the form 1, 2, 3, 4, 5, 6, 7, 9, 10. Okay. So how do we going to evaluate? So I'll take this element 1, which is an A11 position. So I'll cover this particular element containing the row and the column. So it is 1 into 5, 6, 9, 10. Determinant of 5, 6, 9, 10. Then minus 2. The second element, this is positive, negative, positive. So minus 2. Then I should consider the 2 elements. So I'll put that in a circle. So I'll cover this particular 2 containing the column and the row. So it will be determinant of 4, 7, 6, 10 plus 3. Then I'll cover the element 3. Next element is 3. So I'll cover the particular column containing 3 and the column row containing 3. So it will be determinant of 4, 5, 7, 9. So it will be 1 into. So the red indicates the positive and the blue indicates a negative. So upward arrow is a negative. Upward arrow is a negative. So it will be 5 into 10 minus 9 into 6 minus 2 into 4 into 10 minus 7 into 6 plus 3 into 4 into 9 minus 7 into 5. So that is 1 into 50 minus 54 54 minus 2 into 40 minus 42 plus 3 into 36 minus 35. So we'll get the answer 4 minus 2 into minus 2 plus 3 into 1. That is 4 plus 4 plus 3. So that is 8 plus 3, 11. 8 plus 3, 11. So this is minus 4. Minus 4 plus 4. Minus 4 plus 4 plus 3. So we get the determinant value as 3. Okay, so the determinant value is 3. Suppose if we are asked to find cofactor of A31. If we are asked to find cofactor of A31, so the equation is A31 is equal to, that is capital. We represent the cofactor in capital, so it will be A31. Capital A31 is equal to minus 1 raised to, what is I? I is equal to 3 and j is equal to 1. So it is 3 plus 1, M31. So how do you find M31? Where is corresponding A31? So this is A31. Okay, this is A31. So what we have to do is we need to cover this particular element row containing this column containing 7 and the row containing 7. So we need to cover the row containing 7 and the column containing 7. So we'll get the determinant of 2, 3, 5, 6. Okay. Then we have to write minus 1 raised to 4. So that is equal to minus 1 raised to 4 minus 1 raised to 4 into 2 into 6 minus 3 into 5. 2 into 6 minus 3 into 5. So the minus 1 raised to 4, 12 minus 15. That is minus 3. Answer is minus 3. Now, if I ask to find the cofactor of A11, cofactor of A11. So it will be minus 1 raised to 1 plus 1 M 1 plus 1 m1. So it will be minus 1 raised to 2 m11 means this particular element. So I am covering this column and the row. I'll get the determinant of 5, 6, 9, 10. So that is minus 1 raised to 2, 5 into 10 minus 9 into 6. So that is 50 minus 54, that is minus 4. Minus 4. Okay. So this is how we need to find the cofactor, minor and determinant. Hope this is clear for you. Thank you.